This is a lesson on Algebra 1, Lesson 30, Evaluating Functions. Students will evaluate functions. The vocabulary you need to know is piecewise function, a function with different rules for different parts of its domain. Steps for evaluating functions. These are the steps. Find what number is in place for x in f of x. Input x into the function. If it's a piecewise function, input x into the right function. We evaluate the function through orders of operations. So number one, this is how we do number one. It says evaluate f of 6, and the function that they give us is f of x is equal to negative 3x minus 10. So what you do, this is called f of 6, and it's saying whenever I see an x, I'm going to put in 6 in there. So you should put a 6 in here, in this function. So instead of it saying f of x, it should say f of 6, and you should put an x in that function, wherever it says x. So instead of f of x, let's say f of 6. If I put an input of 6, or if our domain is 6, we rewrite the function, but instead of x, we're going to write in 6 minus 10. Negative 3 times 6 is negative 18, minus 10. Negative 18 minus 10 is negative 28. That's your final answer. What this is saying is when we put the function for 6, or f of 6, our outputs could be negative 28, or the range, remember range is the output. Okay. Number 2 is a little bit different in the sense it's asking us to find f of negative 3 and f of 2. When that's the case, it gives us rules. It says for f of x will be equal to negative x only if x is less than 0. But f of x is also equal to x plus 1 when x is greater than or equal to 0. So we have two different rules, and we have two different numbers we're going to start with. So let's start with f of negative 3. F of negative 3, we have to ask ourselves the rule. Is it less than 0 or is it greater than or equal to 0? Well, we know negative 3 is less than 0, so we are going to use this function here, negative x, to put is equal to negative x. Now this is a negative x, so we want to put the x in its own parentheses, so it's going to be negative 3, and we know a negative and a negative is going to really be equal to a positive. So it's going to be a negative 3, which is a positive 3. So f of negative 3 is equal to positive 3. On the next example, we have f of 2. Input in f of 2. We have to ask ourselves, is it less than 0 or is it greater than or equal to 0? We know in this example it's greater than or equal to 0, so we're going to use the second function, or function rule, which is x plus 1. So instead of x, I'm putting in negative 3 plus 1. Negative 3 plus 1 is negative 2. So f of 2 is equal to negative 2. Now on these, it's really important that you do write the function that you're working with. So on the first one, it said f of negative 3. Good to leave it, so you have the function written there. Let's do number 3 now. Number 3, it's saying if I evaluate f of a when it's equal to negative 3a plus 5, to find the range with a given domain. This is our domain, so these are our inputs. Oh, excuse me. These are our inputs here on the bottom. So it's asking us for the output, which is the range. So we need to figure out what's f of negative 3, f of 1, and f of 4. There's only one rule, so we use up one function, which is going to be equal to negative 3a plus 5. So instead of a in this first example, we're going to put in negative 3 plus 5. Solving negative 3 times negative 3 is negative 9. Negative 9 is plus 5 is equal to negative 4. The second one, f of 1. F of 1, put in negative 3 times 1 plus 5 Negative 3 times 1 is negative 3 plus 5 is positive 2. Continuing on, your f of 4, we have negative 3 times a. A in this example is going to be 4. 3 times 4 is 12, plus 5. I'm sorry, negative 3 times 4 is negative 12, plus 5 is negative 7. Okay, so now we have three answers. We have negative 4, 2, and 7. So we have to write out our range. Our range is going to be a set of numbers. So we use the set notation, which is, it looks like parentheses with a little point at the end. And we start off by writing the first output. Oh, this first example is actually supposed to be 9. Not sure where we got that. Okay, it's supposed to be 9 plus 5, which is 14. So we start off by writing our first output, which is 14, 2, and negative 7. And that's our range. That's our output. Okay. So on the last example, it's like the other piecewise function. I'm going to allow you to try to do it, but I'm just going to go through it quickly so you could see the answers. So you could pause the video now, try to do it by yourself, and then I'm going to give you the answers right now. So we should pause it now. And that's the end of this lesson.